don't think you'll think today is too hard, but it's going to take a while. There's quite a few pages.
Is the assignment long then?
I couldn't even tell you. It's been a while since I made it up. Okay, so today we're going to talk about the letter E. And you may not have ever used E in a math class before, have you? No. Okay. E it was discovered by Euler, but actually it sounds like Euler. I always mispronounce it. And what it is we call it the Euler number. We use it when we're doing logarithms. We also use it if you take calculus. You'll see it there too. The actual value is kind of like pi, where it keeps going forever and ever. It's irrational, but it's like 2.718, okay? I did these graphs just to show you that natural log of x and e to the x power are inverses of one another. And we drew inverses before, so just so you have that. So today we're going to talk about natural logs as well as e functions, okay? Here's e to the negative x in blue. Here's negative natural log of x in red, and they're still inverses of each other because if we have this y equals x line and we folded them in half, they would fold onto one another. So where does e come from? Natural log of x is defined as log base e of x, okay? And again, e is 2.718, keeps going and going. Now, one thing that we'll have to do today is convert from an e function to a natural log function and vice versa. Okay, so if you ever have something that says natural log of 4 equals x, what I do is I always think of natural log as log base e of 4 to the x. And then if you have to change that to exponential form, okay, what you would do is that loop again, and you'd get e to the x power equals 4. Okay, so we are going to be doing that today, where we look at natural log, we think of it as log base e, and then to convert from here to the exponential form, you do the loop. All right, so let's go to this page here, and this is asking us to take this exponential and put it into logarithmic. Now, what I do is I always write these like this, and I think of it as a loop. I don't enter the natural log at the beginning. So what I do is I think log, the base is e, the power is x, and this is 8. So I'm just using that log there. E to the x equals 8. Okay? Now, but the final step, you have to write it as a natural log. Log base e is natural log. So all you do is replace log base e with ln. Yeah.
Oh, no. You already answered it. I know.
Oh, okay. All right. Now, if we look at this next one here, again, what I do, I think like what goes here, and what goes here. Do you guys know what would go here? E, here, and here, x, right? Because e to the 5th is x. And then once you do that, the only thing you have left to do is replace log base e with natural log. Good to have you back. All right, So now, like I said, we're also going to be switching from an exponential function to a natural log. And then sometimes we do the opposite where we switch from a natural log to an exponential. Okay? So if I look at this one right here, the first thing I do is I write natural log as log base e of x. And you can do those little squigglies for approximately, or just think of it as equals, that's fine. And now what I want to do is put this in exponential form. So I do that loop. So do you know what I would get? E to the 0.771 equals x. Now, if you can do that without writing it as log base e, you can just kind of think about, okay, there's an e there when it's natural log. You could do your loop that way. I just generally write it like this first and then do my loop. Okay. All right, so this next one, I'm going to do natural log as log base e of 10 equals x. And then I'm going to do my loop, and I would get e to the x equals 10. Okay. Now this here is just putting them together. So sometimes we're going to have exponential and we change it to natural logs. And sometimes we have natural logs and we're going to change it to exponential. So if you look at this one, I have it in exponential. So I'm going to do log. Okay. So again, when you do the reverse of that loop, here's the e, here's the f, here's the x plus 4. Okay, and we want to put that into natural log, and all you would do then is replace log base e with natural log. Log base e and natural log are the same thing. Okay. Now this one is in natural log. We want to put it in exponential. So what I do for these is I replace natural log with log base e. And then I do the loop. So this would be e to the 2x equals 36. Okay. Now if I look at this next one, it's in exponential form. So I kind of think of, okay, if this is log, what goes here, what goes here, what goes here? E is here, negative x is here, and 8, because e to the negative x equals 8. And then we would replace log base e with natural log. And now this is not something I would mark wrong on a test, but when the book gets a negative x, they solve for that. So what they do is they divide by a -1, and they would write this as negative natural log of 8 equals x. So if you gave me natural log of 8 equals negative x, I would not mark that wrong. But the book is going to change it to this. They're going to actually solve for that x. But they don't do it all the time. That's why I'm not going to make you guys do it, because then it's like, well, when do we do that and when do we not? So here, again, I'm going to write this log base something of something equals this. E would go here, 4 goes here, x minus 3 goes here. Okay? And then the only thing I would do is replace this with natural log. Is that okay for everybody? Okay. Now what we're going to do, I put this power table here because we're going to be using that somewhat today. And we're going to go to this. Now that product property and the quotient property and the power property that we learned with logarithms also works with natural logarithms, okay? So if you had two things multiplied and you wanted to separate them, it's called expand them. If it's multiplied, you would add. If it's division, you would subtract. And if there's a power, you bring it out front, okay? That we learned before. All of that works with natural log also. So now let's go ahead and try this. So here's the deal. When you go to do these, where it says, write each expression as a single logarithm, there is sometimes that more than one answer is possible. So what you're going to want to do first, before you start, is look at these two numbers and see if you could write them to a common base. Do you know how 2 to the first is 2 and 2 to the second is 4? They both have that common base of 2. So we want to do that. We're going to go natural log of 2. It's just 2 to the first plus 3 natural log of 2 squared. So all I did is I took that 2 and 4 and made sure they had the same base. Okay? Now, what do you do if I should say this. What you're trying to do now is write everything as one logarithm. So if there's a number out front, you want to do it as a power. So you put this up here. If there's an addition, what do you think we do with that? You multiply, okay? If there's a subtraction, you divide, okay? So what we're going to do here is bring this 4 up here and bring this 3 up here. And we would get natural log of 2 times 4. Okay, so it's just another power. It's not 2 to the 4th, it's 2 times 4. Plus, and if I bring that 3 up, it's natural log of 2 to the 2 times 3 power. So you just have an extra power there that you're multiplying by. So now if I simplify, 2 times 4 is 8. Oh, I forgot my 2, there we go. So I have the natural log of 2 to the 8th plus the natural log of 2 to the 6th. Okay. Now what you do is you try to put them together and get rid of that plus. And to get rid of that plus, we do what again? Yeah. Oh, because I forgot the 2 here. Is that what you meant?
Yeah.
Yeah, I don't know how I did that, but there is supposed to be a 2 here. Sorry. Good question. Okay, now when you try to get rid of an addition with logs, you undo that by multiplying this and this. So what we're going to do is we have natural log of 2 to the 8th times 2 to the 6th. Now this goes back to our rules of exponents. What happens when you have 2 to the 8th times 2 to the 6th? You add the power. So it'd be natural log of 2 to the 14th, okay? And our answer is going to be 14 natural log of 2. So when you take it from here to write it as an answer, they want it as a single log, natural log, They want no pluses, no minuses, and no power. So you bring that power out front. I'm just going to grab my notes here because I don't remember it being 14. But let's check. Oh, I know what I did wrong. I put my 2 as a power here. This should have been 2 to the 4th power. Do you guys get that? This 4 is a power. This 3 is a power. So then I would have natural log of 2 to the 4th. And then this is a 4. Sorry about that. And this is a 6. So then here we would get a 10. And here we'd get a 10. That is our answer. Okay. All right, so this one too, the first thing I do when I first look at it is I think, could I write 16 and 256 as the same base? Is 256 a power of 16?
Power of 4.
16 squared is 256. This one, you could take 16 down to a power of 2. You could take 256 down to a power of 2. You could take 16 to the power of 4 and this to a power of 4. But the easiest way, 16 squared is 256. So I'd probably just leave this as 16 and write this as 16 squared. But any of those ways you do it, you'd still get the same answer. Okay? So let's rewrite this, putting these numbers, or that 4, as our power. Okay? So we have natural log of 16 to the 4th minus natural log, and what if we say 256 we can write as 16 squared. Now we're ready to put those together. How do you undo subtraction? Division. So what we would have there is natural log of 16 to the 4th divided by 16 squared. Now we're back to our rules of exponents. What do you do when you have 4 things on top and 2 on the bottom? You subtract. 4 minus 2 is 2. Where are we going to have that 16 squared? On the top, right? Because 4 is bigger than 2. So we can now write this as natural log of 16 squared. Everybody okay with that? Now there's 2 different ways you can write this. And like I said, every once in a while, and I'll have to be aware of this when I give the test, is that you could write it one way, I could write it the other way, so I'm going to have to check your work. So here's one way. Does somebody want to say one way to write this? Yep. And that's absolutely fine. Okay. Another way that some people would write this is they would square that 16, which is natural log of 256. Both of these are okay. I guess if I was saying which one I prefer, I'd prefer this one, but it's absolutely okay to do this too. Okay? All right. Now, the first thing I always do is I look at the 6 and 9 and I think, are both of them a power of the same base? Like 2. Is 6 a power of 2? No. Is 6 a power of 3? No. So because of that, 6 is not a power of anything but itself. Is 9 a power of 6? No. So that means there's nothing we can do to change them to the same base. So what we're going to do instead is just bring these powers up. Okay? So we're going to write this as natural log 6 cubed plus natural log of 9 squared. Okay? Now, that's a plus. So what do we do there? We're going to multiply those together. So we do 6 to the third times 9 squared. Okay? Now what I would do in that one, there's really not much you can do. So what I would do in that one is just evaluate 6 to the third times 9 to the second and get what that number is. So if we went to our calculator, I would just evaluate what's 6 to the third times 9 to the second. Do you guys know how to do 6 to the third? Have I talked about this? Up arrow, 6, up arrow, 3. And then you have to just hit that right arrow times 9 squared. And did you guys get 17,496? So I would leave this one as natural log of 17,496. And you're going to have a larger number like that when these two cannot be written as powers of the same base. Okay, let's look at this one. Could I change 8 and 32 to powers of the same base? 8 is a power of 2, right? Is 32 a power of 2? Yes. So do you guys get that I could say not 2 times the natural log? What power of 2 is 8? 3. Plus 3 natural log. What power of 2 is 32? 5. Okay. Now we still have to bring up these powers. So it's going to be times 2 here, bring up this 3, and it's going to be times 3. And then they're no longer here. Okay? So I have natural log of 2 to the 6th plus natural log of 2 to the 15th. Okay? To undo that addition, what do? Multiply them. So we get natural log of 2 to the what? Do you get that? You would have to, maybe I should rewrite them and then we'll talk about it. Do you get it? Would be like that, which is natural log of 2 to the 21st. And again, when you leave these, they don't want any plus or minus signs and no powers. So how could I get rid of that? I'd do the 21 in front of it. 2 to the 21st is probably going to be a pretty big number. But on that, it really would not be wrong to do that. But I prefer you doing the 21 in front. Okay. All right. So let's look at this one. And here we have an X and a 3. So there's nothing we can do to get those the same. So I'm going to bring this 6 up here and this 4 up here as a power. So I'd have natural log of x to the 6th minus natural log of 3 to the 4th. Okay. What do you do with those two if you're undoing a subtraction? You divide. So we're going to say that's equal to the natural log of x to the 6th over 3 to the 4th. Okay? All you have to do on this one now is get rid of that power, and we can't just bring it out front because that's a division. So what we were going to do, to bring it out front, these would both have to be 4s. So what we're going to do is just leave the powers, 6 here, and we're going to just evaluate what is 3 to the 4th power. You guys know that? 81. Now this is in one thing. Okay? So if we look at this next one, we have, and what's that? This? No, there's nothing you could do to get rid of it. Are you thinking bring it out front? you can only bring it out front if you had like this, where they're both to the same power, you could bring that out front, but there you can't. Okay? Good question. All right, let's go to this one. We have an X and a 4, and again, there's nothing we can do with that. So I'm going to bring this 4 up as a power and this 3 up as a power. Okay? So I'd have the natural log of X squared times 4 plus the natural log of 4 to the 3rd. You guys get that? Okay. Now, that is, I'm going to just rewrite this. 2 times 4 is 8 plus natural log 4 to the 3rd. How do I undo this plus here? I multiply them. So I have x to the 8th times 4 to the 3rd. Do you guys know what 4 to the 3rd is? So you want to evaluate that, and we typically put our number in front of our variable. So we would go natural log of 64x to the 8th. Okay? And here you truly could bring that 8 out front. Maybe not, because there's 2 things. I don't think you can. I think both of these have to be to the 8th to bring it out, so you're just going to leave it like that. All right, so let's go to this page here. Now, what we just did on that previous page is we took something that was apart and we put it together. What we're going to do here is something called expand on natural log, and that's where you have it together, and you want to do the opposite of that and get it apart. Okay, so if you look here, do you guys get that this is the natural log of 24 times x to the 3rd? We want to break that apart, and the opposite of multiply is what? Add. So we're going to do natural log of that first thing, 24, plus natural log of x to the 3rd. Okay? The only thing that you could do here, can you guys see something you could do? Move the 3. So we have natural log of 24 plus, we're going to bring this 3 here, 3 times the natural log of x. So we did the exact opposite of what we did on the previous side. Previous side, we started with this, ended up with that. Here we're taking this and we're expanding it to get something like this. Now, when I look at this one, I want to look at those 2 numbers again and ask myself, are they both powers? Yeah, and they don't have to be powers, in this case, of the same number. What could I write 32 as? 2 to the 5th power. What could I write 125 as? Do you know what power 125 is? 5 to the 3rd. Okay. Now, those are divided. To undo division, we would subtract. So we're going to take natural log of 2 to the 5th minus the natural log of 5 to the 3rd. What could I do still? Bring the powers down. Yep. And that's all I would have to do. 5 natural log 2 minus 3 natural log 5. Okay. Now this next one, we have natural log of the cubed 4th root of x to the 3rd. Now this is something we haven't talked about a ton, but when you have a power to a root. You can write that power. You put this on the top. You put the root on the bottom. Power goes on the top. Root goes on the bottom. Okay? So that's what I did so far, is just change from there to a power. And then there's really only one thing we can do still. What would that be? Put the 3/4 into the front, correct? So we would go 3/4 natural log x. And that is your answer. Okay? Now notice this one has 3 separate parts. Okay? So I'm going to break that apart, and they're multiplied together, correct? So what's the opposite? How do you undo multiply? Add. So I'd go natural log of x plus, and then I'm going to just take this much and say natural log of y to the 7th plus, and then I'm going to take the ending natural log of z to the -5th. Okay? Now, the only thing that I can do from this point is bring those powers to the front. Okay? So I can rewrite this as natural log of x plus 7 goes in front, so 7 natural log of y. The -5 goes in front, so do you guys agree it would be -5 natural log of z? Okay?
So if it's like 3 different terms like this, you don't have to do the division between the top two. If we're trying to do this backwards.
If we're going to do what?
So if we're trying to get, so if we're starting with like the 3 different terms, and we're trying to get the one term.
Yep.
Would we not have to do the division between the last two?
This is all multiplied together. Are you thinking that because
Right.
that's negative,
Yeah.
and you could bring that to the bottom? You could think of it that way. So like you could think of this as natural log of x, y to the 7th over z to the 5th. It would become positive when it goes on the bottom. Okay? So then this would be the natural log of x plus 7 natural log of y minus, because it's on the bottom, 5 natural log of z.
Either one of those are acceptable.
Yes, because you get the same answer. That's a good question. All right. So let's look at this. So I think this middle part right here, if you're going to think anything's hard today, this may be it, okay? What we're going to use is these 2 rules. They're called the canceling properties, okay? So if you ever have a natural log of x and you want to get rid of that, okay? So say you had like natural log of x equals 2, and you wanted to get rid of that natural log of x, there is a property where you can take both sides of this equation, and put them as powers of e. And there's a rule right here that if you have e to the natural log of something, this cancels out, and whatever is left is your answer. So, actually, that's okay the way I did this one. This cancels out, so what we'd have left is just x, and that would be e squared. Okay? So if you ever want to solve for something that has natural log of x, you can take e to the natural log power. The e and the natural log cancel. The x is what you're left with. If I take this to the e to that power, I have to take whatever is on the right side, e to that power. Okay? The other rule that we have is this one right here, where if you had e to the 7th equals 10, and you're like, I don't know how to solve this, okay? And maybe it wouldn't be 10, maybe this would be x, okay? A way to get rid of this e is to take the natural log. Actually, it would be, I could have a number there. Like this. And then if you have natural log e to something, these cancel and this just comes over, okay? So the natural log of e, these cancel and it would be 7 equals natural log of 10. And maybe it's this, that would be an x then actually. These 7s would be an x, and then you would just evaluate this. So there are ways so that you can get rid of an e to the x, or you can get rid of natural log, okay? So we're gonna start out with e functions and solve them. And to get rid of an e, you can do the natural log of both sides, and natural log of e cancels each other out. The first thing I do is I try to isolate my e to the x. So I'm going to subtract 7, okay? And I get negative 3 e to the x equals negative 5. Then I just keep solving for e to the x, so I divide by negative 3. And e to the x equals, do you guys get if they're both negative, it's just going to give me 5 to the third, or 5 over 3? Okay, now I want to get rid of this. And I am going to use this power right here. That if I have natural log of e, they're going to cancel each other out. And to do that, I have to take the natural log of both sides. Okay. Now, natural log of e cancels, and this side I just have that x. Can I type this into my calculator? I can. So let's look at your calculators. We have a natural log e right here. It's below the log e. And we can evaluate natural log. It already gives us a parenthesis. And didn't we have 5 over 3? So we'd go 5 divided by 3. I don't even think you have to put a parenthesis at the end. And did you guys get 0.5108? And they want you to put it to the nearest 10,000. So 4 decimal places. So it's 0.5108. And we got x solved for them. Okay? Now let's look at this next one. First thing I do always is I try to isolate my e. So I'm going to add 5 to both sides. I get 4e to the negative 2x equals 8. I'm still solving for that e, so I divide by 4. And I get e to the negative 2x equals 2. How do I undo that e? Natural log of both sides, okay? So what I'm going to do, I'm going to take natural log of e to the negative 2x equals natural log of 2. What happens to this? It crosses out and I get negative 2x, that's this power, equals the natural log of 2. Now I want to solve for x, so I divide by negative 2, and x equals, and this 2, you have to be careful when you type this in. We can just go natural log 2, either hit enter or put a parenthesis, and then divide by negative 2. So let me see. Is it natural log of 2 divided by negative 2? So we're going to go natural log of 2. You can either do a parenthesis or enter. and divide by a -2, and we're going to put it to 4 places. So it's -0.3466, okay? So it's -0.3466. Okay. Now we have an inequality, but we're doing the same thing. And all you have to be careful of with your inequality is if you divide or multiply by a negative, switch the sign. So again, I'm isolating my e. So I'm going to subtract 7, and I get e to the -3x is greater than or equal to 8. Okay, would you guys know what to do now? How do I get rid of that e? Natural log of both sides. Oh, I put an h. All right, so we do natural log e to the -3x is greater than or equal to natural log of 8. Now, this cancels. We bring down -3x is greater than or equal to natural log of 8. What would I do to solve for x? Divide by a -3. Do I have to do something when I do that? Switch the sign. So I'm going to get x is less than or equal to, and we're going to just go to our calculator and type in natural log 8, enter, or parentheses, divided by -3. Natural log 8, enter, divided by -3. Did you guys get -0.6931? All right. Okay. Now, this one here, again, I'm going to isolate that e, and I get 2e to the 3x is equal to -3. Then I'm still solving for e, so I'm going to divide by 2, and I get e to the 3x equals -3/2. These are gone, okay? Now what I'm going to do is that natural log on both sides. So I'm going to go natural log e, 3 to the x, equals natural log of -3/2. Now you might notice right here that you can't do this. Do you guys know why? What right here is telling me I can't do this? We only talked about this like briefly. You know? You can't take the log or natural log of a negative number. We'll talk about this when we come back.